Principle of designing algorithm. General Objective 3.0 Understand the principles of designing algorithms for common programming problem. Specific learning outcomes at the end of this class. Students should be able to 3.1 Design algorithm for problems involving 3.2 Strictly sequence control structure, 3.3 Selection control structure, 3.4 Iteration control structure. 3.0 Understanding the principles of designing algorithms for common programming problems. Designing algorithms for common programming problems involves structuring a solution that follows clear principles and control structures. The primary control structures are 3.1 Design algorithm for problems involving strictly sequence control structure. The strictly sequence control structure represents a series of steps executed in a sequential order without branching or repetition. Here's an example of designing an algorithm for adding two numbers. Algorithm for adding two numbers, strictly sequence. 1. Start 2. Input number A3, input number B4. Sum of B5, output sum 6. End. In this algorithm, the steps are executed in a strict sequence, with no conditional or low-ping structures involved. 3.2 Design algorithm for problems involving selection control structure. The selection control structure involves making decisions based on conditions. Here's an algorithm for determining if a number is positive or negative. Algorithm for checking if a number is positive or negative. Selection control. 1. Start 2. Input number x3. If xgt 0, A output x is positive, else B output x is negative 4. End. This algorithm uses the if-else construct to determine whether the input number is positive or negative. 3.3 Design algorithm for problems involving iteration control structure. The iteration control structure involves repeating a set of instructions until a condition is met. Here's an algorithm for finding the factorial of a number using a low OP. Algorithm for finding the factorial of a number. Iteration control. Start 2. Input number N3. Initialize factorial as 1, 4. Initialize a counter, E as 1, 5. Repeat the following steps until ILT, N, A multiply factorial by I, and store the result in factorial B increment, I by 1, 6. Output factorial 7. End. This algorithm uses a repeat until low OP to calculate the factorial of the input number by repeatedly multiplying the result by incremental values of I until the condition N is met. These examples demonstrate how to design algorithms using different control structures, strictly sequence, selection, and iteration. The choice of control structure depends on the problem's requirements and the logic needed to solve it. Certainly, here are some objective questions along with their answers related to designing algorithms for common programming problems. For strictly sequence control structure. General Objectives 4.0